Okay, let's continue with our statistics and analyzing data. And another way that you can display and analyze data is through a histogram. So last time we talked about dot plots. So today we're going to be talking about histograms. Now, histograms look a lot like bar models, but there are some important differences. Okay, you can use a histogram to represent numerical data. The table below shows how long in minutes, 25 students spent reading each day. So you can see we have intervals of 29 and then the next 29 minutes and then the next 29 minutes and so forth. So these are intervals of 29 minutes. So they've divided that up, and that's how they ask the question. Do you read between 0 and 29 minutes, between 30, like more 30 or more, 30 and maybe less than 60 kind of thing, okay? So you can represent data with a histogram when it's large sets. So it goes all the way from 0 to 209. And so you'd have a lot of gaps in space there because they're only asking 25 students. So it's not like they polled, 2,000 people. You're going to have a lot of gaps here of where there would be no data if you spread it out on a dot plot. So this is a much better way to show this data, just for the duration of time that it's asking right here. Okay. All right. Let's look at the histogram they created. So here it is. Here are our interval sections right here. Each one is 29 minutes, represents 29 minutes. And this is how many students spent that much time. So here's one, there were three. This data is fairly symmetrical. In fact, it's exactly symmetrical. And the majority of the data is lying here. The majority of students read anywhere from 90 to 119 minutes in a day. And I'm kind of curious if that meant reading time in school and after school, or what exactly that question was that included reading, and how they tracked that data. A histogram is a data display that divides the range of data into equal intervals. It shows how often each interval occurs in the data set. It is usually used for large sets of data. So I said that before. Since the horizontal axis represents continuous intervals of time, there are no gaps between the bars. So you see right here, this is from 0 to 29. The next bar starts at 30 to 59, and the next one's 60. So there's no space in between those. So that's why they're touching. Okay, so the data shows the waiting time in minutes for buses during peak hours. How do you sort data into intervals? Explain your method. So I want you to maybe pause and think about how should you sort your data into intervals? Okay, what's the best way to do that? All right, so let's go ahead and we're going to sort this data. Now this is going to take some time because it just does. Got a lot of numbers here. So the best way to sort data is in either from greatest to least or least to greatest. I always like to start with least to greatest. So I do a quick scan, and I can, from a quick scan, I can see that 50 is my smallest number. Okay, so I'm going to cross that off, and I'm going to see if there are any other 50s in my data set, and there's not, so I'm going to go to the next one. So then next likely would be 51. Okay, so I do a quick scan of all my data. I'm not seeing any 51, 52s, 53s. Let's see all our 50s. We got a 56, most of it 58, 59. Okay, so it looks like 56 is our next one. Did we have a 58? So let's cross out all the 56s. I like to cross out as I'm going. That way I don't miss anything because there's a 57 there. Let's see, 56, 56. Some of you are watching this going, oh, Ms. Brock, come on, are you kidding me? Okay, so we had two 56s, so I want to make sure I have both of those. And then I noticed that there was a 57. Hopefully I'm not missing anything because I'm kind of trying to do this quick. Okay, 58. There's a 58 right there. MMC. And as you reduce your numbers, you're going to see that this becomes a much easier thing to scan for, right? 59. I know I saw one here. Let's see. I think there was only three. Okay. 59, 59, and a 59. Would be optimal if I was switching colors here, but that would take even more time. So let's cross off our 59s, and then we're going to go with our 60s, because I see one right there. I see one right there. So there's another one. There's another one. So 1, 2, 3. Let's see, any more? No. Okay, 61. I've got a 61 over here, and I got one there. And let's see. I'm going to go ahead and I'm going to pause this while I continue this so that you don't have to watch me as I sort through this entire set of data. Okay, so all the data is sorted, and now I could do this next part without sorting the data, but you have to do it eventually anyway, and you can come up with your own if you don't want to write all the numbers out and you just want to write like 50 and write 1 next to it, like there's 150 and 56 too, and you could do that. So the next thing I need to do is I need to break this into intervals. So I have a range. I start at 50 and I go through 73. So I have a range of 23. So I have to break that into even intervals. And so 23 is a prime number, right? So there's nothing that I can divide it by. So I'm going to either go down to 22, but that only gives me factors of 2 and 11, and I don't want intervals that are just 2 each, right? And have to have 11 on my thing, or vice versa, have intervals of 11 and have 2 of them. That doesn't really give you a clear picture either. So you're looking for something that's in groups that are like, depending on the size of your data, maybe 4, 5, it depends, but you don't want your intervals to be too huge unless your data set is like in the thousands, then you could have intervals of 100 or whatever. But ours is only 23, so I'm going to round it to 24, and I can divide that either by 6 and have each one be 6, and then I'd have 4 groups, or I could divide it by 4 and I'd have 6 groups. Okay, so either way, either one of these would work. Probably maybe go this. Let's see what the slideshow is going to have us do. So let's go to the next slide. Oops. Okay, gotta delete that. Okay, so it looks like they went in with intervals of 6. So they have 4 sections, right? 4 intervals, and each interval has 6 numbers in it. So 51, 52, 53, 54, 55. Yeah, 55. So that's 6 numbers. So each one of those, except for this last one, which would probably be shy of that by 1. Okay. All right. So let's go to the next slide and see. So greatest value is 73, least value is 50. There we go. There's your range. You're going to divide it, make 4 intervals. And like I said, you could do it the other way as well. This is what that histogram matching that data would look like. So here's my first range of 50 to 55. Okay. How many students are in that height range, 50 to 55 inches? Whoops. Sorry. Oh, I went the wrong way. What the heck? Okay. So you see, not many students fall into that range here. I'd be interested to know the age of these students. And then here, anywhere from 56 to 61. That is, there looks like there's probably 13 of those. And then this next range, you're all the way up to 18. And then here back down to like, looks like about 8. Okay, oh, there's the numbers right there. Woo. Okay, so the range of 50 to 55 contains 6 numbers. Okay, not 5, 50, 51, 52, 53. We don't know what those numbers are in that range. There could be several that are like here. Well, here there was 1. In this one here, there's 13, but you don't know if there's, if, you know, 6 of those 13 were 56s, or if, so you don't know very many specifics when you're using a histogram. It's more general trends. Okay. All right. Method 2, the data set is choose an appropriate interval to organize data. Same thing here. Method 2, so here's our height. They went with smaller groups, right? So they've divided in 24. So they had rounded up to 24, and they divided that by 8. They wanted 8 intervals, and each interval has 3 in it. Okay. So here you can see this breaks it down even more. So now you can see a little more clear. There's no one that's in that height range of 53 to 55. So the people that were in our first group in 50 to 55, we didn't know. Now we can even narrow that down further, saying they're anywhere from 50 to 52 inches. Okay, and from this you can see that 59 to 61 is a pretty big range, and then here 65 to 67. Okay, so this is like 5'5" to 5'7", and then you get up here, you know, you're at 5'8", 5'10", right in here. Okay, so this would be like Miss Brock's height up here. Okay, next, let's see. So you can see that gives us a little clearer picture of how the varied ranges. Before it was just kind of up and then down, but this you can see the variation there, and you can see that we have nothing here, and these are kind of would be our outliers, right? They're separated, so kind of our outliers there. Choose an appropriate interval to organize data into histograms. So which one do you think organizes the data better, in your opinion? You know, think about it. Which one gives you a clearer picture of actual heights? From the 2 histograms, you can see that using more intervals reveals more of the distribution of data. Like I said, this arch here was kind of up and, you know, pretty clean arch. Where this one is you're like up, and then you have this dip, and then you're back up again, and then down. Okay, so it gives you a little clearer picture exactly, you know, where those heights lie. So like I said, depending on what you're trying to display, those intervals become important. So the 8 interval histogram shows that the value of 50 is an outlier from the data, right? It's separated from the others. Okay, outlier, we had talked about that in that box dot plot from the other day. It stands apart from all the other data. An outlier is an extreme or rare occurrence of a value, which is usually excluded in data analysis. So if we were looking for an average, now remember, this was only one person here that was this outlier. So you could get a pretty good average excluding that one, okay? Let's see, so Ivan drew a histogram on the right. What information is missing? What do you think the data represents? Correct Ivan's graph, share your ideas. Okay, so let's take a look at Ivan's graph, okay? Well, the first thing that I notice is that we have to think about what it represents, right? One important thing when you're drawing a histogram is to label. What is this? Or a dot plot, anything. It needs to have a title, okay? You need to know what this data is about. Oops, let's go back. As it is right now, we could imagine just about anything. So we have some numbers down here, 1 to 5, 6 to 10, 11 to 15, 16 to 20, and 21 to 25. I mean, he's got his intervals are correctly done, right? They're all equal in their distribution. They each have the same amount for each one. We have an outlier right here. So what do you think he would need to correct, if anything, on this? And what information does he need to add? Okay, and we can't really correct his data because we don't know what he was trying to represent, and we haven't seen his original data, right? So we can't make a judgment as to whether this is graphed correctly, but since we have no idea what this represents, it's not very useful to us. Okay. Oops. The histogram shows the number of representatives from each state in the U.S. Congress in 2018. Briefly describe the data. Okay, so when you look at this, you could see clearly that the number of representatives, see, this has a label, so we know that these are the numbers of representatives. We know that this is how often. Now the frequency is always going up. How often it happens is always on your y-axis here. And the intervals are always on your x-axis, okay? We can see that 1 to 10 is the most common number of representatives sent from a state. And it looks like probably it's almost to 40, somewhere in between that, maybe like 37 here. You can see that no states sent 41 to 50 representatives, okay? And we have, looks like maybe one here that sent 51 to 60, and one that sent 31 to 40, and then a couple here, and then a few here. So remember, each one of these frequency marks represents a state. Okay, let's go to the next slide, and I think it's the final one. So interpreting this data, what could you say about this? Okay, data isn't just tables to look at. It tells us something. It gives us information so we can draw conclusions. Had we been in school, then you would have had a DBQ that you would have had to do this with. This is what your fourth quarter DBQ would have been about. So there are 50 states in the United States. Most of the states sent 1 to 10 representatives to the U.S. Congress in 2018. The histogram has a tail to the right, so this data is right skewed, right? Right skewed. Most of the data values to the right of the most frequent value, so the shape of the histogram is right skewed. No state sent that amount of representatives, and only one state sent the largest amount of 51 to 60 representatives. If I had to make a guess, that would have to be three states that come to my mind would have to be California, Texas, or New York with the highest populations, and that's what representatives are based on. So I hope this was helpful to you as you do your work today. Remember, you don't have to just take what Miss Brock shows you. There are all kinds of things that you can look up and find if you have questions, and I would urge you to do that. Become your own instigators of gaining knowledge. Don't wait for it always to just come to you. Go and seek it and find it.